Hey everybody, welcome to another day of learning. We are talking about indefinite integrals again today. Yesterday we talked about our tricks related to polynomials when we take the antiderivative, and today we're going to talk about a little trick to make your antiderivative of a radical function a lot easier. So first thing that we need to be aware of is that when we are given a radical, we need to rewrite that as a fractional exponent. Now again, as I said yesterday, those tricks that we learned yesterday we had done when we were taking derivatives. Same thing here, when we were taking the derivative of a radical, we also rewrote it as a fractional exponent. Again, what do I mean by that? Well, if you have the square root of x, that's the same thing as x to the 1/2 power. So x to the 1/2 power is what I mean by writing it as a fractional exponent. Let's do another one. If I have the cubed root of x, that is x to the 1/3 power. Whatever this root number is, and again here it's an imaginary 2, that number is always what's in the denominator of your fractional exponent. If we have, let's say, the cubed root of x squared, well, that means that we have our x squared term. The 2 still stays as a power, but then the 3, that root value, is again still in the denominator. So again, the top number is the power and the bottom number is the root. Again, coming from your, if it's a square root, cubed root, 4th root, 5th root, something like that. So if I had the 5th root of x to the 7th power, what do you all think it would be? Well, hopefully you came up with the 7 is the power, so that goes in the numerator, and the 5 is the root, so that goes in the denominator. Okay, so these are all what I'm talking about with fractional exponents. And the other thing to be made aware of is, again, if that fractional exponent happens to be in the denominator, utilizing one of our tricks from before, if we have negative exponents, we need to bring that up to the numerator. So you'll see one or two examples of me going through that. So let's get started. We'll get through a couple of examples, and then we'll be done for the day. All right, here's example number 1. So probably the most basic radical function that you can have is the square root of x. So I want to take the antiderivative of the square root of x. Well, again, there is not an overall antiderivative rule for a radical. The rule is, or the process is, we're going to rewrite this as a fractional exponent. So x to the 1/2 is the equivalent to our original square root of x. So now this is what I'm going to look at to take the antiderivative of. Now, we are still using our power rule here, that if I take the antiderivative of x to some power n, we are going to get x to the n plus 1 divided by n plus 1. Now, we have to be a little bit more careful here because of the fractions. So if I use my power rule, I'm going to add 1 to this exponent. Now, if I add 1, that's the equivalent of adding 2 over 2, right? Because that's with a common denominator for the 1/2. So that means my new exponent is 3 over 2. Now, I have to divide by that new exponent of 3 over 2, and we need to make sure to put our plus c. Now, as in the past, if this was a free response question, you could leave your answer like this, but generally we don't like to have an answer where we get a fraction within a fraction, right? You see that we have this little fraction of 3 over 2 within this bigger fraction of our x to the 3/2 power divided by 3 over 2. So generally in this, hopefully you all are thinking, we could do a little keep, change, flip. So we are going to keep our numerator, and we are going to multiply by the reciprocal of the denominator. So this just kind of cleans it up a little bit. So we end up with 2/3 times x to the 3/2 plus c. And that would probably be the best way to write our answer. Now, everybody kind of writes some answers differently. I usually write the 2/3 out in front. This is also, though, equivalent to 2 times x to the 3/2 over 3 plus c, right? You could have written the 2 and the x, more closely together. And sometimes questions even want you to go back to radical form. So I'm not going to be too specific on that. But again, I'm not sure in how they want that set up in Delta Math. So I'm just throwing this out there as another option. You could also put this term back into radical form. So we've got our 2/3. And then radical form, remember, the denominator tells you your root. So if I have a denominator of 2, that means I have a square root. And the numerator tells me the power. So that means I have x cubed. So the square root of x cubed is the equivalent to x to the 3 over 2 power. And then we have our plus c. So these are all 3 different options on how you could write your answer correctly. All right, let's move on to example number 2. All right, so just adding an extra little piece here. Instead of the coefficient being 1, as in the problem before, now we just have a 4. But that doesn't really change much because, as we've talked about, whether you take the derivative or the antiderivative, that coefficient is still just going to stay there. So I'm going to have 4. I'm going to change this cubed root of x to a fractional exponent. So that's going to become x to the 1/3 power dx. Now, as we just said, the 4 is going to stay. So now I have to deal with my antiderivative of x to the 1/3. So we add 1 to that exponent. And when I add 1 and make it a common denominator with the 1/3, that's like adding 3/3. So my new exponent is going to be 4/3. And then we have to remember divide by that 4/3 plus c. Now, just like what we did before, we are going to do a little keep, change, flip process. So pretty much that's always going to end up being multiplying by the reciprocal of that denominator fraction after we do our keep, change, flip. Now, if we notice here, if I go to simplify this a little bit, I have a 4 in the numerator and a 4 in the denominator. That can just cancel each other out. So this actually simplifies to 3 times x to the 4/3 power plus c. And that's how I would leave my final answer. Okay. One note, as I'm just kind of looking back at this problem, notice how in the first 2 steps that I have here, all right, so these 2 steps, I did not take the antiderivative yet, right? My first, this was the original problem, and then when I came over here, that was me just rewriting the problem, but I didn't actually take the antiderivative yet. And because I didn't take the antiderivative yet, my integral symbol has to stay for both of those. It's only now in this 3rd step that I actually did the process of antidifferentiation. This right here is the antiderivative of the original function. It's a little messy looking, right? It's not the neatest answer. That's why we still ended up kind of going an extra 2 steps here to clean it up a little bit. But this right here is my antiderivative. So this is the first step where I no longer need that integral symbol because I have already completed that antidifferentiation process. So I no longer need the integral symbol or the dx. Instead, I'm going to have that plus c. Okay, so your original is going to have your integral symbol and dx, and then after that process, you're going to end up with the plus c. So that's kind of the before and the after of the antiderivative process. All right, next one. Example 3. We've only got one more example after this, and then we will be done. So this one changes a little bit because now that radical is in the denominator. So we've got kind of one extra step that we have to deal with before we can take the antiderivative. Well, the first thing I'm going to do is rewrite this as 3 over x to the 1/2 power dx, right? Because again, like we saw for the first example, radical x is equivalent to x to the 1/2 power. Now, I can't easily take the antiderivative of that. I cannot take the antiderivative of each of those pieces separately. All right, if you have a fraction, you cannot take the antiderivative of each piece separately. All right, so I have to rewrite this one more time where it's going to be most beneficial for me, and the most beneficial setup for me is when I can deal with just having a power rule antiderivative. So what does that mean I'm going to do? I'm going to bring this term, bring it up to the numerator, and that means the sign of my exponent is going to change. So the 3 stays, but what happens, that x to the 1/2 when I bring it up to the numerator is going to become x to the negative 1/2 power. Now, we usually don't like dealing with negative exponents, but this isn't my final answer. This is only a process within my, one step within my process. So this is what's going to be the best situation, though, for my antiderivative to be taken. So now let's take the antiderivative. That coefficient of 3 stays. My x value, again, using my power rule, add 1 to that exponent. So I'm going to add 1, which is going to be pretty much 2 over 2. So that's going to become x to the positive 1/2 divided by 1/2, and again, my plus c. So as I was just talking about on the last slide, I went from having the integral symbol and the dx before I took the antiderivative, and then after I took the antiderivative, those two things went away, and I have my plus c here instead. Okay, now just one extra step to clean this up a little bit. I've got 3x to the 1/2. Now we're going to do, again, our keep change flip, so that means I'm going to be multiplying by 2 over 1. And so just a final answer here, 3 times 2 is going to be a coefficient of 6, x to the 1/2 power plus c. And that is my final answer. And again, just because I did it in the first problem, let's do it again here. If the question had asked for you to put it in simplest radical form, right? If they want your answer in radical form, that means that you can't leave your variable with a fractional exponent. You would have to put it back into radical form. So that x to the 1/2 would become radical x plus c. And again, just be careful when you're going back to radical form. It's only the x value that is to that 1/2 power, not the 6. So if any of you guys were thinking to do the square root of 6x plus c, that is not correct. Okay, that one is not correct because it's only the x value that's being raised to that 1/2 power, not the 6 as well. All right, let's move on to our final example for the day. This is probably, the most complicated type that you would see out of these problems. So, just like the last ones, first thing we're going to do is rewrite it. So, I've got a 2 in the numerator, I've got 5, and then x, the cubed root of x squared. Well, again, that 2 is the power, so that's going in the numerator of the fraction, and the 3 is the root, so that goes in the denominator of the fraction. Now, be careful here when you're figuring out what to bring up to the exponent. It's only the x value, not the 5. So that 2 over 5 there, I could just rewrite as 2/5 if I want. And then the x value, if I bring it up to the numerator, that would become an x to the negative 2/3 power. So that could be one way that you write it. Somebody else might also think, okay, well, it's 2. I bring my x value with the negative 2/3 over 5 dx. Either one of them is correct. My personal preference is this one over here because then I can see the 2/5 as my coefficient separately from the variable that I have to do the power rule with. So it really is up to you, but again, this one on the left is the one that I utilize when I am writing or rewriting my original antiderivative function statement. And again, the reason why is because now when I take the antiderivative for the first step, I just see right away 2/5 is a coefficient, so that one's going to stay. X to the negative 2/3 power, well, if I add 1 to that exponent, get a common denominator, that's x to the 3/3 power, right? Because 3/3 is the equivalent of 1. But it just has a common denominator now with the original fractional exponent. So negative 2/3 plus 3/3 is 1/3 as my new exponent, divided by 1/3. And we've got our plus c. So just cleaning this up a little bit, x to the 1/3, do our keep change flip, so we're multiplying by 3/1. And finally, one last step here, 3 times 2/5 is going to be 6/5, x to the 1/3 power plus c. And that is what I'm going to have as my final answer. And that's pretty much it. Hopefully you guys are okay with what just went on there. You know what? Let's just do one more radical form here in case. Who knows? Just in case. All right, so 6/5, x to the 1/3 would become the cubed root of x. That's a little messy. The cubed root of x plus c. So again, that's another option for you to have. Again, I'm not sure right at this point, I apologize in advance, which of these the Delta Math assignment would prefer. It might be the radical one. So again, that's why I just kind of wanted to go over that again. And hopefully everybody's doing well out there. As always, please let me know if you have any questions. And you guys are going to move over to now your Delta Math assignment to do some practice problems. All right, everybody have a great day. Bye-bye.